All right, we have the senior A-level tournament of towns, question 5, and I want to present a student solution who got this correct. Cyrus from Queensland, okay? Only student to get this question correct. Uh, and basically what Cyrus did, okay, so the question is you have a triangle and you have these angle bisectors. So you have the altitudes meeting at H, and the foot of the altitude is A1, C1, B1, and then you have these angle bisectors that bisect HBC and hits HC at X. And you do the same thing for Y and these others, the 6 points. And the question, and then if you take Y, A1, X, and you take that angle, and that angle, and that angle, and you add them up, the question is like, what is the angle sum? All right. So I want to present a student solution to this, and it's using trigonometry. Okay, so what he does is he breaks it up into these angles. Instead of having 3 angles, you have 6 angles. Okay, and if we call this angle theta, I guess the first sort of lemma Cyrus proves is that tan theta equals C over A. So C is the length. This is the length C. This is the length A. Okay. And the way he proves this is he does a sine rule on this triangle to get so hy over sine theta equals ha1 over sine y. Okay, and then we do another sine rule here to get by over, and then so this is sine of 90 minus theta, so this is cos theta, and you get ba1, and it's sine 180 minus y, but that's also just sine y. Okay, and then you combine these and the sine y's cancel, and you get tan theta equals ba1 on ha1 times yh on by. Okay, and then what you can do is you can notice that ba1 on ha1 is just tan of this angle, which is 90 minus this angle, which is 90 minus this angle. So this angle is just c. So this is tan c, right? And yh on bh by the angle bisector theorem is just hc. So this is hc on bc. Okay. And hc on bc, if we use the sine rule again, so hc on sine of this angle, so that's just cos c. So this thing is equal to cos c, and then bc on sine of this angle. So this angle, if you notice, is equal to this angle. Okay, and because this is cyclic here, that's 180 minus the a. So this is just going to be cos c on sine a. Okay, and so then it's tan c. So then you get the cos c cancels with this cos c and the tan to get sine c. So it's sine c over sine a, and then by the sine rule, this is the same as c of a. Okay, so that's quite nice. And then once you got this angle as c over a, then by symmetry, all the other angles are going to be like, so there's going to be one where the tan is going to be, it's going to be c over a over c, b over a over b, and then it's going to be what's left, a over b over c and c over b. Yeah, and so we want to know the sum of the angles. Okay, so here we have the sum. So if the tan of the angles are reciprocal to each other, then the sum of the angles are I mean either 90 or 270, right? but they have to be 90 because, well, so both angles are acute. Yeah, all these angles are acute, so they can't get over 180. So basically, if we're adding all 6 up, then the angles that correspond to these things, they give you 90 degrees. Yeah, and so there's 3 lots of 90 degrees, and so therefore the whole thing gives you 270 degrees. And this problem was worth 10 points, and it's basically, if you just solve this one problem, I think it's enough to come like second or equal second locally. I think someone solved like 1 and 2, and someone solved like lots of if a bunch of people solved question 1, and then some people solved like 1, 3, and 4. Yeah. Okay, that's it. Yeah. So nice showing in the tournament.